Hey guys, today we're going to look at question 1G of the 2017 MAT exam. The question tells us that for all values of theta in the range between 0 and 2 pi, the line y minus 1 times cosine of theta, which equals x plus 1 times sine of theta, divides the disk x squared plus y squared less than or equal to 4 into two regions. Let a of theta denote the area of the larger region. Then a of theta achieves its maximum value at how many values of theta? And we're given 5 possible answers. So let's get straight into it. I've started by sketching out a circle of radius 2 about the origin. This is going to represent our disk. I've also written out the equation and the line that we were given, and this varies with theta. We want to rearrange this to get an explicit equation, i.e. in y equals mx plus c form. If we divide by cosine of theta on both sides, we'll get y minus 1 equals x plus 1 times tan theta. And doing a bit more rearranging gets y equals x times tan of theta plus 1 plus tan of theta. So we have a gradient of tan theta and a y-intercept of 1 plus tan theta. The best plan of action is to plug in a few values of theta to get an idea of how this line behaves. For theta equals 0, we get y equals 1, because tan of 0 is just 0. For theta equals pi over 4, we get y equals x plus 2, because if you remember, tan of pi over 4 is just 1. And for theta equals minus pi over 4, we will get y equals minus x, because tan of minus pi over 4 is minus 1. So let's sketch these lines on our diagram. Y equals 1 will be a horizontal line through y equals 1. Y equals x plus 2 will go up here, like this, and y equals minus x will go down here, through the origin. Hopefully you can see that by changing theta, all we are doing is changing the gradient of a line that goes through the point minus 1 and 1. And as theta ranges from 0 to pi over 2, this line is going to go full circle. Recall that a of theta is the area of the larger of these two regions. So for y equals 1, it will just be the area below the line. Y equals x plus 2, it will be to the right and below. And for y equals minus x, it splits the circle in half, so you can take either side. We don't actually need to work out what a of theta is. We just need to realise that a of theta is maximised when the line is equal to y equals x plus 2. So theta equals pi over 4 produces this line, but the catch is that there's also another value of theta that does this as well. A property of tan is that tan of theta plus k pi for any integer k, this is equal to tan of theta. This means that tan of pi over 4 plus pi equals tan of pi over 4. And so we found another solution, and this is valid because it's in our range of 0 and 2 pi. In fact, these are the only two solutions to this problem. Hence, going back to the question, we see that a of theta is maximised by exactly two values of theta. So the answer is B.